Hello, everyone. I'm Dan Dumbacher, Executive Director of AIAA. We welcome you today. We are pleased to have you to host today this Aerospace Perspective Series webinar being presented by the MITRE Corporation. Space debris is a serious problem we must address now to avert a catastrophe in space. Please allow me to share a few numbers with you to set the stage. More than 1,500. That's the additional pieces of debris now floating around in low Earth orbit because of the reckless and irreversible Russian anti-satellite test last November. Another 13,000 small satellites will be added by the Chinese when they deploy a large constellation to provide internet services. Then consider the US licensed companies that have already launched more than 2,000 satellites of a planned tens of thousands of satellites over the next decade. All of this must be added to the approximately 40,000 objects currently being tracked by US Space Command. I cannot overstate it. This is an urgent problem. Tens of thousands of objects that are traveling at roughly 17,500 miles an hour in low Earth orbit are threatening launch vehicles, space assets, and human lives. Space debris management coordination is a top priority at AIAA. Our task force, led by Sandy Magnus, is working every day to address the issue for the benefit of society and the industry. Today, the MITRE Corporation has assembled an outstanding panel of government and industry experts who are going to tackle the challenge of making space transportation safer for current and future space travelers. We appreciate that so many in our community share our concern on this topic and have joined us today. We also greatly appreciate our panelists and Carrie Buckley. Now, I would like to turn the program over to our moderator, Carrie Buckley with MITRE. Carrie, it's all yours.
Great. Thank you, Dan. Thank you very much for that wonderful introduction, and good afternoon to everyone joining the webinar online. Thank you for participating today as we discuss this very challenging and timely topics, space debris mitigation and management, and look to lay out what really could be this better future and what that would look like. Dan did a great job describing the current environment in terms of the number of active and planned satellites that are orbiting our planet. One thing Dan didn't mention, in addition to that, we also have about 2,500 dead satellites and tens of thousands of articles of debris that are larger than a baseball, and even more if you look at objects that are on the size of a penny. Again, looking at the consequences of that, certainly as described in a recent Aerospace America's special report, any one of these pieces of debris could, and again, depending on the location, destroy a satellite or even poke a hole in a crew capsule or a habitat and potentially cause depressurization. And the risks don't stop there. For example, this past Saturday, China launched a Long March 5B rocket and is allowing the re-entry to occur at random. So this rocket is very large. It is likely that several thousands of pounds of material will survive re-entry and impact the Earth, as has happened with previous uncontrolled Long March 5B re-entries. So at the MITRE Corporation, as Dan mentioned, and I know all of my panelists here and many of those in the audience are very involved and concerned about making space operations safer and better integrated for all. So the panel of the topics will certainly resonate with me personally, and I know they will with all of you as well. So this afternoon, I'm very fortunate that I have a terrific panel of experts joining me with varied backgrounds in space, and I am excited to engage with them on the desired end state for the space environment. As important as this vision, I'll also ask my esteemed panel members to lay out some tangible actions that can be taken for today's audience to achieve the desired end state, which is a better space operating environment for all. There will be some audience participation, so please get involved. There will be some audience polls, as you'll see here in the chat window. I think Vicki may have already warned you of that, so look forward to hearing what you have to say. And then I do plan to leave some time at the end of the session to respond to questions submitted during registration, as well as live questions being asked here in the chat. So before we jump into questions, I invite each of our panelists to very briefly introduce themselves to the audience, and we can start with Jim Cooper. Over to you, Jim.
Hi, everybody. I'm Jim Cooper with MITRE Corporation. I'm the lead there for SSA Solutions and Business Development. I'm here today, though, representing the Space Safety Coalition. For those of you that aren't aware, or those of you that are aware as well, the Space Safety Coalition is an ad hoc coalition of companies and organizations that are actively promoting responsible space operations and space safety through the adoption of the existing relevant guidelines and regulations and standards that are out there, as well as the development of a best practices, a living best practices document. So I'm here representing the SSC today.
Thank you, Jim. Steph, let's turn to you.
So thank you, Carrie. I'm Steph Earle. I'm the manager of the Space Policy and Outreach branch in the Office of Commercial Space Transportation. And so most people are familiar with the fact that the FAA licenses the launches and reentries of commercial space vehicles and as well as spaceports. And so orbital debris is very near and dear to my heart. I've been working orbital debris issues and space traffic management issues for about a decade for the government. And I wish I could say we were further along, but we are slowly progressing. And so I hope that today we can explore a few of the different areas and I can provide my unique aspects where I can as a government rep.
Great. Thanks, Steph. Dan, we'll turn over to you next for introductions.
Hello, everyone. My name is Dan Hawk. I'm Oneida. I'm Native American. Native Americans are known for being caretakers of Earth, and now it's our opportunity to be caretakers of space. I'm here to represent that portion of space management and space debris management. Thank you.
Thanks, Dan. Let me just ask, I know Marlon was having a few troubles earlier. You might have audio. Marlon, are you with us?
I'm probably not going to be here on video, but I am here on audio.
Okay.
So I'm from the Aerospace Corporation. I actually lead our Center for Orbital and Reentry Debris Studies. As you noted, one of the things that's also been keeping me busy recently is the reentry of the Chinese Long March 5B. You can actually monitor that at our website at aerospace.org. We keep projections going on when large objects are going to come back. I've been working debris issues all across the spectrum for 30 some odd years now, including things from basic research like getting to blow stuff up to working the policy side of it.
Great. Very good. Thank you, Marlon. All right, well, we'll get started. And Jim, I'm going to start with you with the first question here. So the question is, when we have fixed or resolved the space debris problem and the challenges of space sustainability, what will the space environment look like? What's the future of space, and what does it mean? Like, what will it feel like when we have no more debris problems in terms of space operations?
Yeah, thanks for the question, Carrie. So first off, I don't think we're ever going to not have any more debris problems. I hesitate to use the word fixed. We're always going to have debris. We shouldn't be thinking of this as a zero debris problem, right? I mean, we're human beings. We're going to create trash. That's part of our nature. The problem here, the thing you want to think through, though, is how do we control that, right? So what we want to get to is sort of controlled and active management of the space environment and the space debris concerning it. It's a problem we control. We control trash here on Earth with things like people putting trash into receptacles and the garbage men coming and picking up, once a week at your home or something like that. We need to think through those sorts of problems. But we'll never have like zero debris creation. You're always going to be launching stuff into space. That's going to come with the creation of at least some debris. You're always going to have some issues with some accidents on board. There's a lot of debris up there today that could collide. You might have a piece of debris versus another piece of debris, and we really can't do anything about that yet. Maybe in the future with active debris removal, but that could create more debris. So you're always going to be seeing some of these situations continue. And of course, you're going to have some of those non-cooperatives out there. Somebody was mentioning, of course, the Russian ASAT. You're going to be seeing still, I think, moving into the future, some of those non-cooperative entities, and how do you bring them into the fold, and what does that look like moving forward? So I wouldn't think of it as sort of a zero debris creation, but an active and controlled management of the space environment. Now, how do we do that? There's sort of several phases to this. Obviously, the first thing you want to think about doing is designing your spacecraft and designing operations and concepts of operations around those spacecraft to not create or limit the creation of new debris. Let's not create a bunch of debris. I like to think of, you know, trying to put this into problems that maybe the layman is familiar with, right? We if you remember the old McDonald's quarter pounder with cheese, it used to come in that styrofoam container, and they stepped away from that. Why? Because that styrofoam container lasted a long time, right? So they repackaged. We can do things like that. We can control in the design process the creation of new debris. We can control things like how long objects will last on orbit after their end of life, and how quickly can we dispose of them? How many years should they be up there? Should they actively re-enter? You mentioned the Chinese rocket body, which will be entering next week, uncontrolled, right? Those are problems that can be handled in the design process to limit the creation of that debris. The next step then that we want to think about is the on orbit, right? What's going on while we're on orbit? How do we mitigate, prevent, if you will, the creation of new debris on orbit? How do we not create new trash while we're up there? And of course, with that comes the idea of very active and very complete and timely and responsive space situational awareness and space traffic coordination and management measures around that to let operators know what the situation looks like around them. Make sure that they've got the decision quality information necessary to be able to do something about a particular problem, to avoid a potential conjunction, to perform a collision avoidance maneuver, to carefully and safely re-enter their spacecraft, those types of things, right? So we want to make sure that we're on orbit, not creating new trash. And then the last problem here is going to be with debris remediation. You've got to pick up the trash that's up there right now. There is active debris remediation that needs to be done. There are large pieces out there that cause significant amounts of risk, more than some of the other debris that's out there. And studies have been done to show what those objects are. It would be good to be able to go and pick up those large risk objects, for instance. Even if satellites and operators design great end-of-life disposal into their systems, accidents are still going to occur. Nothing works 100% safely 100% of the time. You might still need to go pick up an active satellite that has ended its mission, but something has gone wrong with its end-of-life disposal system, right? That's that debris remediation piece. So that's kind of what I think the operations should look like. How do you get there, right? What do we do to get to that sort of stable management of the space environment? With that comes, of course, the development and the adoption and the acceptance and the national and international implementation of a holistic set of guidelines and principles and standards and regulations, you know, all of those types of things that, of course, are going to promote and enable and make things like capacity building happen, technology innovation that can wrestle with some of these problems and resolve some of these problems. Develop better algorithms to create better space situational awareness, better conjunction assessment practices. Data sharing is a big one. How do we sort of transparently make sure that the international community and the users and the operators can share the necessary data to make the assessments that need to be done, and then make the decisions around things like collision avoidance maneuvers. All of that's going on today. It's sort of a virtuous cycle that feeds off of each other. And that just needs to continue. It could be brought together, I think, better. It could be coordinated better. But I'm happy to say that the virtuous cycle is happening today and moving forward, and that just continues and needs to continue. So I'll turn it over to somebody else.
Thanks, Jim. Very comprehensive list. I'm wondering, Marlon, based on what you heard from Jim, certainly pushing back on the idea that it will never be completely fixed, but there are things that we can do to mitigate, both from a design process and orbital maneuvers, space debris remediation. Anything else, Marlon, that you think we should be thinking about in terms of a cleaner space environment for safe space operations?
Yeah, certainly. One of the practical things that I've run across actually is even the question of, you know, okay, if we can't get it to be zero debris, which we probably can't realistically, what can we live with? What is acceptable? What is better than acceptable you know, that's a big and very dynamic question. It's one of the problems we've done, you know, we've had over the years working on this problem, and, you know, working with other countries and other organizations is trying to figure out where the acceptable limit is. What do we need to be targeting so that we can specifically say, well, okay, if we're going to this target of the amount of debris, the amount that it interferes with our operations, what do we need to do? And we're not at that point yet. And actually, one of the problems practically that we've seen is, of course, depending on who you're talking to, there are different perceptions about what's acceptable, what's okay, and the difficulty is you can't really start leaving people out when you're talking about space, because, you know, all you need is one bad actor to cause problems. So, you know, as an example, as we were discussing this launch of the Chinese rocket and letting it come back uncontrolled, you know, based on U.S. rules and some of the ones that are commonly used, that wouldn't be something that would be acceptable. It's way too big. The risk is too high. But the rules that we operate off of, the ones that the Europeans operate off of, similarly, are not universally accepted, because you've got that different perception of what constitutes accepted. And as you can see, that's a problem, because we're not all moving toward necessarily the same target. And you know, if we don't do that, well, what we need to do is we need to talk some more about it. We really need to sit down, figure some of this stuff out, and then get people to start thinking early on, okay, this is what I need to do, this is where I need to be going. And I know it doesn't sound like an exciting action item, but it is actually absolutely critical. And I can't tell you how many hours I've spent trying to do this and how important it is.
Marlon, I would very much agree with that statement. I'm going to follow up that observation in just a moment. Dan, first of all, I want to hear from you. What happens if we do nothing? And then I'm going to leave it to the group, because I will be following up on the question about those guidelines and who needs to sit down. My question to all of you after Dan's response will be, who should we be looking to do that? Who should be the one who's putting pen to paper and drafting some of those guidelines for us? But Dan, first, if you could just share what happens if we do nothing?
Well, if we do nothing, we know that we have an increased launch cadence. We're going to be putting up another 40,000 satellites or so in the next decade. So that in itself will cause debris. Once you have satellites up in orbit, then there's two ways that you cause debris. One is through collision and the other is through explosion. And from a Native American perspective, you know, we're using industrial hemp for rocket fuels, and hydroxyammonium nitrate is a monopropellant that's stable. So that would prevent some of the explosions through hypergolic fuels. So that's one of the areas that Native Americans will be working on to prevent debris in space. So doing nothing is, for one of my friends, David Finkelman, he mentions it, he says to me, he says, we will not know when a collision happens until after the collision happens. And partly because space is so big, and that the probability of conjunction and is very, and risk is very small. It's really small. So I think that, you know, on our typical, with our ability to track right now, I think it's you know, 35 meters is the accuracy of any conjunction event. And right now, I think particularly, I don't think that we have one set of data that we particularly use. So when we talk about conventions and norms, we need to identify a specific norm that we're going to be using for the data itself to determine whether or not a conjunction is going to occur. And then we have to have people, you know, like a space safety coalition or others coming together to say, is this really going to be a conjunction risk? And once we do, then we have to have consensus saying that it is, and then we have to have norms saying what we're going to do about it. So if we have satellites that have the ability to maneuver, then should they maneuver? And if they do, if they collide with something else, what is the liability of that? So I think there's a lot of questions that need to be answered regarding that. but doing nothing is not going to be helpful. I think that when we're moving in the direction of space situation awareness and space domain awareness, I think that is good, but I also think that we are probably using too much energy, I believe, in mitigating a risk when maybe the risk doesn't exist. So I think we need to look at that a little differently, because in order to move, right, and out of maneuverability, you have to have the fuel to do it. So we ought to be conservative in what we need to do, but also at the same time, make sure that we avoid a collision if possible. Thank you.
Thank you, Dan. I know that from looking at the chat already, there's a lot of interest in the concept of risk and the evaluation of risk. So I think you hit on something of critical importance here. So let me just circle back one time here. If anyone wants to share, we talked a lot about kind of the rules of the road, norms of behavior, the conventions that are needed. I had the opportunity to sit down with General Raymond, commander of the U.S. Space Force last weekend, and he absolutely agrees. Who should we be looking to capture those norms and that guidance?
You wanted me to go first?
I'll leave it
Okay.
to.
Well, you know, Native Americans, as I pointed out in the beginning, that, you know, we are known for caretakers of Earth. And here we are, we're looking at creating our own launch facility, our own launch capability. And we have space debris now that we have to mitigate before we can even launch. Now that's not the way it's supposed to be. So you have to understand that, you know, when it comes to being caretakers of space, we have to realize that, you know, it affects everyone, and we have to have the ability to. Oh, sorry, got lost here. My computer just went dead.
Well, we can still hear you, Dan, but you know what?
Okay.
Yep. We can keep
Okay.
going.
My screen is blank. I'm going to keep talking for a bit. You know, caretakers of space is important, and I'll just leave it at that because my computer's not working properly here. So I'll pass it on to.
All right. Thank you, Dan. All right. With that, I'm going to turn it over to Steph now. Steph, I'd love to know what you think the biggest unresolved problem blocking progress toward the future state of debris management is. Do you think is it a technical problem, policy, cooperation? What are your thoughts on that?
Well, so that's a good question. And I think what we're hearing today fits in with the fact that I don't think we really have scoped the question fully. We have a lot of questions about it, and I think you're right. You can look at it technology, but I would argue that the technology exists today. And if you match that technology up with economic drive or lack of economic drive, I mean, that's really the issue. Who's going to pay for it? I mean, the technology exists to do it. And as Jim mentioned before, we're talking about debris mitigation. We're not talking about debris elimination. And even remediation, when you take in remediation, it's a cost-benefit analysis. What are we remediating? We can't get it all. We can't get it all. So what are we going to do, and what are we going to go and grab? And so it really comes down to the question of, what are we supposed to do? And if you know what you're supposed to do, you basically have to know what you're measuring. And I would argue that perhaps in some of the discussion we've had today, we've talked about two different things at the same time. You know, the Outer Space Treaty talks about impact and liability, but it also talks about interference. And so we've heard the fact that you could have a collision and you could create space debris, but is that creation more of a problem than the impact of that debris on active satellites? And so if you were going to launch to say 550 kilometers, and you say, I've got a maneuvering capability, so I'm going to maneuver at every warning, and so therefore I'm not going to be creating debris, do you have a problem still? Well, you might still have a problem because you may be doing an awful lot of maneuvering at 550 kilometers. And that might actually impact your mission. And so I'm wondering, are we actually measuring what we really want to change? Is it the impact of orbital debris or the fact of orbital debris? And I think that a lot of our measures simply go to the amount of orbital debris. You know, that's what we're looking at. And perhaps we're not actually getting to the traffic management that I would argue we really hit in other areas where we look at traffic, road traffic, aviation traffic, maritime traffic. We're not looking at eliminating air traffic. We're looking at managing it in a way that allows us the most efficient use of that airspace. The same thing with the roads. We're managing the roads so that we have the most efficient use of those roads. Are we managing the space debris and space objects so we get the most efficient use? And that's where I think the sustainability argument comes in. So your question is, what is the largest problem? And I think it's the question.
Good. So I'm gonna actually point to the second most upvoted question so far, because it gets to a little bit about what you were just talking about, and I think falls right in your domain. And it's just a question from the audience asking, does space, it just disappeared on me, does space debris affect the safety of launches? And is this taken into account when looking at launch windows?
Yeah, so this is one of the things that, you know, the FAA is basically in charge of the on-ramp and the off-ramp to space, and a little bit of on orbit when you get there. And so it's one of the really only traffic management functions that is in place today. Is if you are going to launch and you would impact someone else's active satellite or the space station, you're not allowed to launch. That doesn't happen on orbit. On orbit, both parties get a warning and someone hopefully does something. But there's no there's no enforcement. That's not the way it is for commercial launch, for launch. For launch, we have done basically a comparison. What can we do? What's the cost of holding a rocket on the ground for 5 minutes versus launching with the risk? And we have said in our regulations, and other countries as well, have said that the issue here is we're just not going to launch. And so we do have a collision avoidance requirement where we look at the on-ramp, and if there's going to be a collision, but we can only go so far in that physical analysis. When we do that, you can only propagate so far before the error is too big. And you've got to let launch operators launch. Now, the issue that I think they're really getting to is how thick is space? How complicated is it getting now? And the answer to that is it's definitely getting more complicated. We are seeing more and more impacts, and we have to look at it from a safety perspective and say, what is the safest route that we can still get to space? So is this, you know, do we look at the single most risk? Do we average the risk? How do we do that? And another thing I will point out, I kind of mentioned, is space launch is one-sided. If you're a satellite on orbit, you're not told that a launch is coming your way because we hold them. And so there's no real risk to them, or at least there's no exceptional risk to them. That's not the same on orbit. On orbit, we tell both parties, but launch is a little different in that regard. But we are looking at the density of space and how that really impacts. And the greater your fidelity in launching, like I know exactly where I'm going, the easier it is. But if you're a first-time launch operator, you're burning to extinction, so you're not really targeting a specific altitude, you're just going to let it burn. And so that's when we need a larger safety buffer. Those are the missions that are most impacted by orbital debris. So collision avoidance is just an ongoing and amazing field, and a lot of math. Let's just say that.
Good. Thanks, Steph. Marlon, I'm going to turn it over to you next. So we just heard quite a few actions that need to be taken. We have some of it technology, some policy, some cooperation, and others. From where we are today, right now, what do you think is the most important next step?
Well, I gotta say, you can't see me, but I was kind of cheering as Steph was running through a bunch of the list of things he was talking about, because it's all the same kind of things that I'm seeing. That the issues are, a lot of the real practical issues are not the technical ones. It's all the rest of it. Deciding where we want to go, what the real issues are, and actually the launch collision avoidance is an interesting case study in that. And we've been doing launch collision avoidance for years and years and years. And one of the practical things that comes out, you have to consider when you're doing this balance, is is okay. I'm looking. I'm making sure I'm not going to come close to anything that I can see with my launch vehicle. But if my goal is to try to protect my launch vehicle, there is a whole lot more stuff that could kill my launch vehicle that I can't see at all. And I am living with that risk because I don't have any choice. And it's considerably greater than the risk from the objects that are flying around that I can see. And, you know, this gets back to that whole question of what are the real issues? What kind of balance do we have between the effort that we have to put in and the benefit that we're going to get out in terms of, you know, debris mitigation overall? And this is not to say that I don't think we absolutely should be doing a whole bunch of stuff with debris mitigation. I spent my whole career working on that. But it's critical to understand what it is that makes a difference and what doesn't make a difference, and where do we put our efforts, because it does require effort, it does require money, it does require people to change the way that they're doing things, and you want to make sure that that's going to be beneficial. And we've spent huge amounts of computer time, and we still continue to trying to understand that problem of what works, what doesn't, particularly in the new world we're dealing with space and all of the stuff that's changing. A lot of what we thought worked in the past may not work now, or we may need to modify it. And we need to get ahead of that rather than waiting until it's too late and going, oh shoot, we need to do something about it.
Good. Turn to Jim. Jim, do you agree? Do you have, and it's interesting, we asked to poll the audience too, what they think some of the biggest roadblocks are toward progress in this area. Looks like there's a non-cooperating international actors is something that folks feel might be one of the big pieces here that's keeping us from moving forward, as well as some potential political roadblocks and unchecked proliferation of low Earth orbit objects. Thoughts on what you just heard from Marlon, or what we're getting from the audience?
Yeah, picking up on what Marlon and Steph were saying earlier, from you know, what is the biggest problem? I would not point to technology. I think technology is something that can and is being overcome by industry as they move forward through this, as well as others. So I don't look at that. The policy standpoint, for me, I think there's a lot of good guidance out there right now. Not that it cannot mature, it absolutely can mature. And some of the things that the other members have already talked about, as it matures, we really need to think through, you know, how does it mature around, like Steph was saying, the idea of impacts, not just numbers of debris, but what's the actual impact, and how do you, as Marlon was saying, you know, how do we get together and figure out what needs to be studied and continue to have that discussion? But again, I think that the policy and the guidelines that's out there is already a pretty good starting point and can continue to evolve. Cooperation is, from my standpoint, probably the biggest problem. It is difficult to bring all of this together, even amongst those that are cooperating. You've got 50 plus different international, national, trade association, ad hoc coalitions like SSC. You've got 50 plus of these organizations and entities out there working through a lot of these problems. How do you bring all of that together? There's a lot of great movement. You just had in June the Secure World Foundation put on their Space Sustainability Summit. The Space Sustainability Rating from EPFL was launched. I think that's a good thing. Academia is involved through things like the Space Safety and Sustainability Initiative out at UC Boulder. The UK just announced a new effort to shape their policy and start doing more on this. All of that's good, but really, how do you bring all of that together to move forward as effectively and efficiently as you can? You're in this virtuous cycle right now, and it all kind of feeds off each other. But I'd like to see that, you know, maybe made a little bit more effective. And then how do you bring in the non-cooperative actors, right? I mean, if I had to point to any one thing right now and say, you know, what's the very next step, you know, try to focus on the next best thing to do. I think that argument is maybe a little bit specious because it all needs to be done. And I'm not sure we need to waste time and effort thinking about and trying to get agreement on what's the next best thing to do when it all needs to be done. But hey, a great first step, we can internationally condemn, cease and desist all intentional fragmentation events. Because I think that you'd have trouble with having most people argue for that. It's good for nobody that operates in space and is a huge risk factor for everybody. So I would point to that as maybe your number one thing that could be done. The US government has made an announcement on that. Others have followed, and that's been great. It would be great to see that, you know, sweep the world basically, effectively.
Good. Thank you, Jim. Dan, I think we still have you on audio. So I'm going to
Yes.
turn the next, excellent, great. I'm going to turn the next question over to you. So I think as we've all said here, we've been talking about this for quite some time. I think we all agree that progress is needed, and we've just identified some areas in which we would like to see that done. But it seems that action really is lagging significantly behind some of these conversations. So my question to you is, what can members of our audience do to get their respective organizations really to move forward to a better operational environment in space? What are our asks?
Okay, well, first I'm going to go back to Jim a minute here. So, when we talk about, well, first of all, Native Americans, we are now part of the Space Safety Rating and the Space Safety Coalition. So we're a part of that. So when we talk about going into space, we're going to be doing that in a responsible way with others, and we're not going to be rogue. So that's one of the things. And on a technical point of view that I think we missed previously before answering the next question is like, from a Native American point of view, when we go to space, I don't believe that we're using debris sat knowledge the way that we should. So when you do have collisions that happen, right? So it matters on how the spacecrafts are being built and the materials that they're being built out of. So from a Native American point of view, when we're looking at industrial hemp to be able to mitigate a collision when it does happen, to be able to minimize the amount of debris. So I think that's important that I believe now, like even our CubeSat capabilities now, that we don't use the debris sat knowledge, and that's something that we need to talk about. So when we put things in orbit, we put our satellites in orbit, that they, if they do take a hit, that they are that they have the ability to withstand those kinds of collisions, even though we're talking about 7 kilometers a second. And so so from a Native American point of view, again, right? So we are basically a third party. We are, we're part of the United States, we're part of Canada, but we have indigenous people all over the world. And so what happens is space unites us, right? So as indigenous peoples from all over the world, they can come together and they can go to their respective, governments and say, from an indigenous point of view, these are the things that need to happen in space. These, this is how we believe space should operate. Being, cleaning it up, doing it, launching in a respective manner, limiting the amount of constellations and satellites that go up, having the ability to be able to deorbit at end of life, and those kinds of things are very important. So I think, even though we're talking to the audience, what can they do now? I know I'm also speaking, worldwide to the indigenous people around the world to be able to do the same thing. So from the audience point of view, is that they can talk about it, and maybe address it to their Congress and their senators and say, look, hey, space is very important. Of all the things that are happening in the world today, space is one of the most important because we rely on it. And I'm looking at it from another, from the minority point of view again now. So if we have weather satellites as an example, we have a hurricane that's coming, and we need that weather satellite to be able to predict that that hurricane when it hits. And so what we found out in, what we call environmental racism, right? So the idea there is, the hurricane hits, and where does the debris go that's on land? The debris goes to where we have the people who are voiceless and don't have that opportunity, and that's where the debris goes. So it's very important that we have our ability to monitor things in space, that have the ability to say to our indigenous people around the world, especially in climate change in our northern territories, that have the ability to monitor, climate change and habitat and their resources. So from a Native American point of view, that has to happen. And so when we project that to our audience, what we think is good, should be good for the audience too. And it makes sense, I guess, if you want to be able to use our space in a way that supports all of people on Earth. And indigenous people are, we're here, we're not going anywhere, and it's important to us. So that has to happen.
Very good. Thank you, Dan. I think you made some very important points to include perhaps helping, having this audience who are here with us today help communicate the urgency and understanding of the importance of space in our daily lives. And I think that's something that can really help move the conversation forward. Let me see, Marlon, let me turn it over to you. What do you think in terms of what the audience can do in terms of taking action?
I think one of the biggest things I've seen practically is just start thinking about debris issues very early on in whatever program you're working in, whatever part of this process you're dealing with. Because, I've had, I don't know how many cases where you've run up against the, you're getting close to a launch, you're getting close to doing your operations, whatever, and they'll say, oh, shoot, I'm not going to be doing my debris mitigation. I've got to go back and fix something. It costs a lot of money, and that's one of the things that gets complained about. The reality is, in a lot of those cases, if you thought about it in the beginning, you would have planned things in, and the net effect would have been to cost you nothing. And this is, I think, one of those really key ideas is, we're constantly working this whole cost benefit idea for protecting the space environment and what we have to do for it. And one of the things you can do to significantly decrease the cost is think about all this stuff earlier, plan it in, and then it doesn't become such an issue, and it's easier to do the right thing. And I think the space community in general, if they can take that back with them and introduce that early on, I think that can fundamentally make a big difference all the way across the community.
Very good. Thank you, Marlon. So Jim, I have intentionally been waiting to ask you the question from the Space Safety Coalition perspective. What actions are you taking to improve space operations, and what can the audience do to join the coalition?
Yeah, thanks for that. That's a good and relevant question here. So in all of this, right, as we're talking about, have a voice. I think that's a little bit of what we're all saying is participate, get out there, and have a voice in this and help us out, because it's a big problem and it needs to move forward. There's a lot of venues to be able to do that in, but one of them is the Space Safety Coalition. As I briefly introduced up front, it's kind of a first of its kind ad hoc coalition of organizations and entities from around the globe. It includes space operators, trade and industry associations, and the like. And it's a place where we're coming together and trying to voluntarily get people to voluntarily adopt guidelines, relevant standards, and regulations and stuff like that, and get them to voluntarily adopt that, as well as we're coupling that with our own internal development of a best practices document that helps figure out how to sort of adopt that and implement it, right? It's like we were saying, there is I think some decent starting guidance and some decent starting policy out there, but really it boils down to how do you interpret that from a national perspective? How do the national entities interpret that and then implement it? And so what we're doing is working on a best practices responsible space behaviors document. That's a living document. So we're continuously looking at that across all of these organizations and trying to come up with those ideas on how people can go ahead and implement this stuff. So we're open to all space operators, all entities and whatnot. If you're interested in joining, you can go to the spacesafety.org, spacesafety.org website, or contact us at info@spacesafety.com. And those are ways to get in, or just contact me if you want to go that route, and I definitely can hook you up with that. But the important thing here is, again, sort of get out there and have a voice, participate, get out there and learn what it is, bring your ideas to the table, because nobody's got the whole picture on this. We're sitting here and talking about, all of us are talking about how do you look at this problem? What are the right things to consider? How do we reach some of this agreement? There is always going to be room for new innovation, new thought, leadership in this. So, go out and find one of those organizations. But obviously, we would say from MSSC, come join us. We're happy to take new members.
Great, thanks, Jim. I'm going to turn to a question that came through from the audience poll, but something I think we had talked about it as a group and has come up here as well. And that's really the impact of kind of what's happening in space from a climate perspective, and specifically some of the long-term impacts of burning up debris that we have on the upper atmosphere. And the specific question is, what is about the ozone layer depletion via aluminum oxide production? And so the question is, what are the long-term impacts of debris burning in the upper atmosphere?
Wow, that's a very good question.
Mhm.
And I saw that one in the chat. I thought, I hope she doesn't ask that. I'm kidding. Not all rockets, and I'll do this one because it's mostly a rocket related question. Not all rockets burn the same fuel. Not all rockets contribute the same emissions. It's very difficult to try to understand that. So let's start off with what is being put into the atmosphere. For starters, we do have an environmental regulation which looks at the impact of launch vehicles on breathable air. So basically, all the air that's churning at the bottom of the atmosphere that you could breathe, launch vehicles have to comply with environmental standards there. It gets a little more difficult to understand when you start getting into the upper extremes of the atmosphere where the emissions are actually being directly injected. And I've seen 3 or 4 different news articles recently that anybody can go and Google that start talking about the impact of climate and these emissions at that level. And so there is, but I would argue that these are very small events. They're still contributing. And just like Jim's example, one Big Mac wrapper wasn't a problem. Or maybe it was a Whopper, he said. I think it was Big Mac. But one was a McDonald's guy. So one of them wasn't a problem. It's the compilation of all of them. And that can probably be said. So what still needs to be done is more analysis in this regard. Is it bad? Yes. How bad? Unknown at this point. I think we're still trying to guess what is, and that's not the right word. I think we're still trying to estimate and understand, the benefits of space to humanity versus the cost of space to humanity. And so while we look at these, obviously we would, if we'd have no launches, we would have no impact. But that's not the case. And so also, if we were to say just solid rocket fuels, which are the ones that primarily contribute to aluminum, I believe is what they were looking for. Those are primarily solids. So do we say that no solids and only liquids? I don't think we're there yet. I don't think we've done the research. And that's one of the questions that I think leads to what you said earlier. You asked, what can the audience do? And Jim and Marlon have hit on it. If you're a launch operator or you're a satellite builder, think of orbital debris early. Think of the climate early. Things like mercury thrusters might not be the best thing for the environment. And if you're not a builder or an operator, if you're an analyst, you're an inventor, or you're an environmentalist, get involved. We have a Richter scale. We have an F scale for tornadoes. We don't have anything for orbital debris or climate. And those things are, they're developed by people, groups, and organizations who researched and looked into it and understood it and came up with something that they convinced the rest of the world, this is useful. The Richter scale is useful. We don't have that today. And so that's where I would ask for those analysts, inventors, environmentalists. You don't have to be on a rocket team to help contribute in this area.
Okay. Thank you.
I can add to that.
Oh, please, yes, thank you.
From Native American point of view, when we have an end of life and we deposit our satellite, over the ocean, we're going to be using as much as we can industrial hemp to mitigate that issue of aluminum. So I think there are things that we can do, getting back to the debris sat again, to be able to build our satellites, our equipment in space in a way that's more sustainable to begin with, so that when it does burn up in our atmosphere, that we have less of a problem to worry about. And I think that's, getting back to, what is the research on that, what we can do. But sometimes I have to suggest that, things make sense when you're using sustainable materials compared to, aluminum as an example. In this case, plant-based materials. So I think that we have to look at it from a different point of view. That's just what I'm saying.
Right. Thank you, Dan. I'm going to combine a few questions here. And one of the most upvoted questions is something that we talked about already, and that is what branch of the government should be in charge of space environmental management. And then we also had a poll, and the poll was asking about which organizations should take the lead in actions to improve space. And we see here that a lot of folks bring up the space industry and the organization's commercial space. And we haven't talked too much about that yet. And I know that I had an opportunity to sit down with many space operators and on the government side, private side, as well as insurance companies and such, and really emphasizing the need to convene and hear the voice of the commercial space companies and operators. So I'm going to do a double barrel here. My first question to you all is what do you think, and how can we convene and hear the voices of commercial space, especially as we're looking to bring on new innovations? And second is kind of the carrot and stick question. So we hear about regulations as an option, and there's a specific question here that says, can space debris be mitigated or managed by applying a tax on the way like a carbon tax is to turn the tides on Earth? So if you could, and I'll give it over to as a free for all, whoever wants to jump in on any component of that question in terms of the role of commercial space and the sticks and the carrots to incentivize good behavior. Who wants to go first?
I'll jump in.
Okay.
Again, when it comes to, let's say, the Space Safety Coalition, which we belong to, I have to say from a Native American point of view again that we have to hold others accountable, including Space Safety Coalition or Space Safety rating. If we feel that there's something not right, we have to say something. We have to do something about it. So when it comes to what organization might be best to look at that, I again would appeal to, let's say, the Native American community, indigenous people, in part because I'm believing that's more unbiased, right? And so I've had questions come out to me about, the significance of, the space industry itself, monitoring, their capability in space as far as, space safety. But then again, I believe that when it comes from an indigenous point of view, that maybe Native Americans have something to offer when it comes to how we deal with the space environment. Again, getting back to the very beginning, we're caretakers of Earth, and now we're going to be caretakers of space. So what does that mean? That means that we have to look at these things that are coming at us in a different way to say, is this really what we want to do? Is this really responsible? And how can we help and support it from a tribal point of view?
Good, thank you. Anyone else want to add to that, or?
I'll jump in. Oh, Jim, you want to go first?
No, go ahead, Steph. I'll follow you up.
Okay. So your question there, I was disappointed the government only got 49%. We lost to industry, but I think the question really was loaded because it says who should be the lead, and there's so many different areas here that I think almost all of those in that group have a leadership role in some way. So voluntary consensus standards are voluntary. We need the industry and the industry associations to develop those, because that really helps inform what the government can do, what can be done from the government. Obviously, the government regulations can be heavy-handed, but it doesn't have to be heavy-handed if the industry is already there. And then in that case, the government is really only looking for those outliers, companies trying to cut corners or something to that effect. And so I do think that there's a role for almost all of those to take a leadership role in all of those different areas about who should lead in these areas. I really don't think there's really just one case. But you also asked about a carrot and stick. So, being the regulator on this, we have an enforcement ability, just like all the other regulators. And sometimes it's required because everyone, countries, companies, they act in what they believe is their best interest. And sometimes that may be a short-term best interest. Sometimes they're very noble and it's a long-term interest, but they always act in their best interest. And we've seen this on the national level from other countries launching upper stages. They believe that an uncontrolled reentry is worth the risk to get what the activity they have in mind done. And so do you need to have a carrot and stick? And I think sometimes you have to have both. Yes. Go ahead, Jim.
Oh, Jim, you just put yourself on mute.
Thanks, Steph. You kind of said almost what I was going to say, but I'll just back it up. The industry is there right now. They are already engaged in a lot of these things, these sort of voluntary measurements and everything like that. And industry is at risk, right? So it's going to be our commercial, our industry operators and stuff like that are going to do this because this is their livelihood effectively if this doesn't work out, right? But also if they're not, I don't want to use the word controlled, if they're not sort of monitored and encouraged in the right way through sort of where Steph was going, the government action, the regulation, hopefully not overdone or anything like that, you do run into an issue of having a tragedy of the commons. And that's something that we, through industry by itself probably are not going to be able to resolve that, right? So I think that's where government does come in and take the lead role in that. So I think there's room for both. There are going to be places where industry takes the lead. There are going to be places where government takes the lead. And it all needs to happen, like Steph is saying. And I think to a certain extent, it is all happening. But again, it is that sort of coordination and cooperation problem. How do you bring all of those guys together? The carrot and the stick issue is interesting. The stick obviously is going to come with things like licensing and regulation. And that needs to be, a right-sized stick, if you want to use that term. But there are carrots that can be done here too. I mean, you can look at, if it's done smartly, you can look at things like technology transfer. You can look at things like data exchange. You can look at, really figuring out how to do standards properly so that people that are coming into this can understand and have sort of a common framework to work from. Those are all things that can be very encouraging to help people work through some of these issues and want to be part of this. With that, though, has to come some transparency as well, and some understanding that we do need to do a better job of sharing some of the necessary data that's out there and figuring out how to do that in a protected manner. And I think those are efforts that need to be maybe pushed forward a little bit. You're always going to have those folks that want to, like Steph is saying, focus on their sort of national priorities. From a commercial standpoint, they're going to want to protect certain proprietary and competition sensitive types of things. Those are issues that really have to be worked through if you want to do that carrot properly. But I think there are ways to do that carrot, tech transfer, data sharing, standardization that can be done.
Great. All right, we have only 2 minutes left. I wanted to give Marlon a chance to add anything that he has not heard yet, and then we will wrap some things up. We've got some fantastic questions around the role of the UN, where people can go and find more information on space debris. And so anything you want to say about that, Marlon? Last comments over to you, and then we'll wrap things up.
Okay, yeah, just to pile on the everybody has a role, that is definitely the case, and they're all different from, the government saying, kind of being the source of saying maybe this is where we need to go, helping people think about that, to organizations like the Space Safety Coalition, who are kind of thinking out there about where we want to go, to companies actually implementing things or getting involved in things like the Space Safety Coalition, getting involved in more formal structures like standards development, things like that. And one other carrot and stick thing I want to note is, because this is a global problem and a single organization can go boom and cause a mess for everybody, there's a problem because you don't necessarily have a stick for everybody. And that's one of the issues that we've got to deal with. But I think the key out of all of this is just getting everybody to take some action, to think ahead, to not look at this as the last moment. I think that's the critical part out of all of this, especially the way that space is changing. And there's so many other organizations that involved than there were even 10 years ago. And it's critical that they all have some involvement. They all feel they've got skin in the game with all of this, because it's not going to work. It's not going to work if we're not able to get everybody involved. Again, in a shameless promotion, I will note that at the aerospace website where we're following the reentry, we do have a bunch of stuff on background of debris. Obviously, from the CORDS group that I work, this is like the center of what we do and worry about. So, you know, there's one of the many sources of places that you can get information. European Space Agency, I would suggest going to the NASA Orbital Debris Program Office website. All great sources of information that really can give you some good background.
Great. All right, you did it, Marlon. Thank you. You answered all those questions and you wrapped things up very nicely. So with that, that really does conclude our time for today. I want to thank our panelists for sharing your time, your unique perspectives, and certainly your expertise. And very much want to thank our partner on this webinar, AIAA. I would say as we move forward, I really encourage each of you to reflect back on the challenges and the action steps that you heard discussed today. Some great conversations happening there in the chat as well. Network with each other, to take some tangible action to make improvements. We really need to act now to ensure security, resilience, and sustainability of the space operating environment today and into the future. So I know I speak for the whole MITRE Corporation when I say that we would welcome the opportunity to work together with you as we strive to improve space and fulfill our mission to solve problems for a safer world. Have a great day. Thanks for spending time with us.
Thank you.